Okay, see Lindelof videos. Solving trigonometric functions on an interval for a specific value. So here's the interval that we're solving on, is 0 to 2 pi. Keep in mind that the reason that an interval will be important is because let's pretend that this is the sine function right here. Right, it goes up and down, up and down, up and down, etc. It does that forever in this direction, forever in that direction. So what we want to know is in the first 360 degrees, in the first 2 pi, what happens? When does it accumulate those values? So we're looking from here to here. Otherwise, this thing goes in circles forever, and we couldn't pinpoint a specific value. So let's try this. I think it's relatively reasonable. So let's give it a chance here. All right. So all I'm going to do here is just act like this is algebra. So algebraically, to solve this, you would add 3 to both sides, wouldn't you? So plus 3 to both sides. And you would get 4 cosine squared theta equals 3. So this is still pretty much algebra to me. We're just going to make some changes here, right? So I'm just going to solve this algebraically. I'm trying to get cosine by itself. So I'm going to divide by 4 on both sides, divide by 4. If you don't want to move my math to the right, and that would give us cosine squared theta equals 3/4, right? So now what we have in front of us is this little problem here, don't we? We have this cosine squared. So we want to get rid of the squared, just like in algebra. How do you get rid of a square? You take its square root. And remember, when you take the square root of a whole thing like this is really important because this is where people mess up a lot. When you do this, what you're really doing, so I screwed that 3 up, didn't I? What you're really doing is taking the square root of the top and the bottom. So I'm taking the square root of this and this. When I take the square root of a whole fraction, I'm taking the square root of the numerator over the square root of the denominator. Where the square root of cosine squared theta is just cosine theta. And the square root of 3, frankly, is the square root of 3. And the square root of 4, however, is plus or minus 2. So we have a plus or minus 2 at the bottom, right? Square root, negative 2 times negative 2 gives us 4. Positive 2 times positive gives us 4. So we have both of those values. Last thing I'm going to do is quickly go to the unit circle and see where I find these values, right? So the two values I'm looking for are negative square root 3 over 2 or square root 3 over 2. I find those values 4 times on the unit circle, kind of here, 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 and here. And those values actually come back in radian form as pi sixths, 5 pi sixths, 7 pi sixths, and lastly 11 pi sixths. Anything more than that, I'd be in a second turn. I'd be past 2 pi, right? So I'm started at 0, including 0, which is here, and I went all the way to 2 pi, including 2 pi, and these are the values I got. Hey, thanks for watching. I hope it was helpful. If you haven't already subscribed, please do. If you have any comments or questions, please let me know. I appreciate it. Take care.